All right, so today we're going to be talking about Raylib. So Raylib, you can go to raylib.com and you can click on download. It'll ask you for money if you don't want to pay them. Maybe you should pay them, I don't know. But if you don't want to pay them, just click take me to the downloads and save it. And then after you download it, click on the installer and it'll install. And then you've got Raylib installed on your machine. Now, the cool thing about Raylib is that it's very easy to write code. Like, here's the entire program for this game. Like it's moving a 2D shape around. I'm using the arrow keys to move it around. And this is the entire program right here. Like, this is literally, okay, thank you. This is the entire program in C++. And it's not bad. You know, it's got a couple constants for the size of the screen, one function to make a window. It's got a vector 2. Vector 2 is just holds a x and y, basically. Then while window should close is not true, then it just checks to see if a key is pressed. If it is, then it moves the ball position 2 pixels in that direction. Begin drawing, clear the background, draw the text, draw a circle, and drawing. If this looks like DRM GUI, it does have some kind of DRM GUI feels to it. But that's you know, that's it, and you've got something, right? Even more right left. Let's see, 2D camera. Right. Not a lot of code. Okay. So it's got functions for like drawing rectangles. Now there's 3D stuff also as well. So let's convert here. This one looks kind of cool. So you can see it's got Raylib spelled out in cubes. And you have to set up a projection matrix. That's one of the reasons why I've been kind of telling you guys about all the 3D stuff. Is like, if you're working, you know, outside of Unreal Engine, then, you know, you have to kind of set up a projection matrix. Loads the texture. Update camera. Begin drawing. Okay, so update camera, I think uses it does a lot of stuff for you. I think it actually eats your. Let's see. I think it might eat your input sometimes. And then it's going to just draw the models over and over again, and that's it. Like, that's the entire thing, right? Like, it's ridiculously easy to learn, to use. First person maze is using the mouse input here. Okay, I can walk around. We got a little Doom client. You can go right through the walls, maybe. I don't know. Nope. Looks like it just bounces or something. Okay, so they even got collision. All right, cool. And so that's a Doom client right there. Kind of cool. It's kind of cool. Raylib's pretty neat. It's named after our good friend Sean Raymond here, who is the author of Raylib. Hello. Nah, it's named after me, William Raymond. No, it's named after the other 5 Raymonds. Okay, so what you're going to do for your next homework assignment is you're going to install Raylib, and I want you to go through some of the examples and just kind of see the things that exists, and then just modify one of them. Okay. And none of these programs are like particularly big or hard to learn. For this one, you just use the arrow keys to move around, and when there's an intersection between a rectangle and a sphere, right? You guys remember doing that? Then it highlights in red. So over here, got a camera projection. The player is at XYZ 0, 1, 2. Player size is 1 in the X, 2 in the Y, 1 in the Z, so I guess Y is up. Ray San is the guy's name. Ramon Santamaria. It's already gone from your brain. What's gone from your brain? Oh, how to do the collision between a box and a sphere. Yeah. Well, as it turns out, check collision box sphere is a function. So there you go. So if there is a collision between two boxes, you can use check collision box. There you go. If you want to know if there's a collision between a box and a sphere, there's a function for it. And so it just passes in the player's bounding box. It passes in the sphere right here. And a sphere is just a position and a radius, right? And then it'll set collision to be true if they're colliding, false if not. Yep. And then when it actually draws, so you can see the code here takes arrow keys, it slides the player around in the X and the Z direction, because in Unreal Engine, X and Y are the floor, kind of. But Unreal Engine's weird. It does not follow standard conventions. It's the only game engine that has its combination of X, Y, Z axes, and I think it's left-handed even. So all the stuff we've been talking about with like transformation matrices and things like that, and collision, stuff like that, it's gonna probably help you here. Okay, so it just checks to see if there's a collision. If it is, it sets the Boolean called collision to be true. It's got some input on the keys. They'll move the player around. And then the actual rendering of the game world, you call it begin drawing, clear it to the background color of Ray White. Begin mode 3D, makes it a 3D thing using the camera as the projection matrix. Set up the view frustum. We have a solid 50B class this semester. All of us forgot how to do this. Yep. You draw a cube, and this is the enemy box, which is this one. And then draw cube wires, which is, what is that? Interesting. I don't know what that is. Okay. Draw cube wires and boxes. So I guess it's drawing the wireframe on top of it. Draw the enemy sphere, draw sphere wires, draw the player, draw cube V, player position, player size, player color, and draw the grid, which is the floor here. And in mode 3D, then it's back in 2D mode. It's going to print the words to the screen. And it's going to draw the frame. Or draw the frames per second, sorry. And then it's going to draw the frame. So that's about as easy as, game dev gets, you know what I mean? So at the end of last semester, spring, you might remember, Megan, I was like making a game. It's kind of like Minecraft, where you like click, like place blocks on the ground kind of thing. Do you remember that? I don't understand how program can set frame rates. Do you mean like figure out the frame rate, or like, what do you mean? Like cap it? You set target FPS to whatever you want the maximum FPS to be. That's how you do it. Yeah, so what you do typically, and there's probably better ways of doing it, is that every time you start a frame, what you do is you get the current time, and you have a variable that holds the last time. You delta them, like you said on chat, and then that's going to give you like, I don't know, a millisecond or something, and then you 1 over a millisecond, and that's your frame rate for the frame. Usually, though, they'll probably average it out across a couple frames, so it doesn't flicker up and down like rapidly. But so if you want to cap the frame rate, what you can do is just sleep, right? So let me show you a hidden technique that only my students know about. So what's the frame rate we're going to get on this? What do you think? Pretty good? What do you think? Yeah, very quick, right? As fast as the thing can go, it's going to print out hello world, right? Now, let me show you this technique that only my students know about. They can go to sleep. All right? So, I thought you meant a legit tactic. So this is inside of food used H. And so that is going to go to sleep for 10,000 microseconds. So if we do that, you can see it's now updating 10 times a second. So we could do int max FPS equal to 30. And then what we could do is take 1 million divide by max FPS. Now, of course, if a frame takes longer, then we're gonna go below 30, right? Like we're not capping it; we're just slowing it down quite substantially. And so, what you should also do is get the current time and see how much time has elapsed to figure out how much you should use sleep for. But this will be good. So 30 times a second, we get that. Okay. If we set the max frame rate to 3, then 1, 2, 3, 1, 2, 3, 3, 4 time or something like that. Okay. Okay. So the way that who called my class? You almost fell asleep in 26 today. When you ran into Lewis for putting those things on the. It's funny. Okay, so if we want to do this properly, because like what if we have something here that just takes a lot of time, then we're going to sleep for an entire second after something already taking a long amount of time, and it's actually going to dip our frame rate way below 1, right? So this is typically what we do, right? So we'll have like a integer last time, last frame time, and like I said, there's better ways of doing this, but this is a fairly standard way of doing it. And so last frame time equal. Do you guys want to see the C way of doing this, or do you want to see the C++ way of doing it? The good way? Nah. All right, so clock. That's in C time. The correct way of doing this is using chrono, by the way. I'm just going to show you the way that I learned it back in the day. Nowadays I'd actually use chrono. So you do that, and then okay, so current, and so we would say. So it's like 55. Oh, right, because this is CPU time. This isn't wall clock time. That's why. Okay. So the amount of CPU time it's been has been quite trivial. That's not wall clock time, which is how long it's been. Because sleep doesn't cost any it doesn't cost any actual CPU time when it sleeps. So we would need to use Chrono to actually get the actual time. It's called wall clock because you look at the clock on the wall and it tells you the current time. But this is basically what you do. So clock is CPU time, unfortunately. So it's not going to give us what I'm looking for here because sleep's going to mess it up. But basically, it's gonna measure how long it's been since the last time we called it, and then we can divide 1 over that. Basically how many clocks per second there are divided by the difference will give us the frames per second on it. But again, this is CPU time. We need to get wall clock time instead. So. Time is seconds. Yeah, we need to actually switch into Chrono to do this. And we're out of time for today. So that's the general idea, though. Does that make sense to you? So basically, at the start of every frame, you get the current time, and then you can measure how long it's been since the last frame. And then once you know that, then you pull out that much. Equals per frame time minus last frame time, and then you can pull that out of how much you sleep. Okay. So if you have a really long computation, then you don't sleep as long, right? So you can keep it capped at a very constant 30 frames a second or 60 frames a second. Then you can keep yourself from overheating your graphics card or whatever. So you want to hear the slight chuckle when Kearney reads the above. Kearney DM'd me before class started and said, "Hey, ask about FIPS, bro. Lol. Sorry I broke the NDA, Kearney. Had no choice. They were onto us." Illusion of choice. That's funny. No, there was no expectation of doing FIPS on this, but it's like honestly delta time, which is this. Call it delta. That's something that you basically are always going to have computed on a game because you want to know how long your frame time is, right? How long is it taking per frame? Because a lot of computations in a game will use that. Like if you're moving every frame, you have to multiply by delta time in order to get a constant time per second. If you don't, the higher your frame rate, the more you're going to move. Like if you move a meter a frame, if you have 100 frames a second, you move 100 meters. If you have 30 frames a second, you move 30 meters in a second, which is bad. And so you have to multiply by the frame time. It's like if you're getting 100 frames a second, then your frame time is 0.01. And so you move 0.01 of a meter every frame, and then you end up moving 1 meter. If you have 30 frames a second, 30 times a second, you move 1 over 30 meters, and you move 1 meter a second. And it normalizes everything out. This is something that's going to be computed in every game engine that's worth its salt. You do not want a game that plays differently if you have a faster graphics card or something like that. It'd be dangerous. Okay, so that's it for today, guys. Thanks for coming out. Play with the Raylib examples. It's really easy to use. It's great. I love it a lot. Mod it, and I'll see you guys on Thursday. Peace.